The lesson objective for this video, students will use proportions to solve geometry problems. So before we can do that, we need to know some additional properties of proportions. The first property is the reciprocal property. If two ratios are equal, then their reciprocals are also equal. So if A over B equals C over D, then B over A is going to equal D over C. So basically all you're doing is you're flipping them. So if you flip them over, they're still equal to each other. The next property is tells us that if you interchange the means of a proportion, then you form another true proportion. So when I'm talking about the means, I'm talking about these values right here, B and C. So if B and C trade places, it's still going to be equal. And so we'd have A over C would be equal to B over D. And so in essence, it's like looking at the original proportion sideways. If you look here, you've got A over C, B over D. So it's kind of like turning the proportion on its side. And the third property says that in a proportion, if you add the value of the ratio's denominator to its numerator, then you form another true proportion. So if A over B equals C over D, then A plus B over B will equal C plus D over D. Now, at first you look at that and you think, that doesn't seem like that should work. But it actually does work if we go through and figure out the cross products for both sides. If I cross multiply the first proportion, I get A times D is equal to B times C. And if I cross multiply the second proportion, I get D times the quantity of A plus B is equal to B times the quantity of C plus D. So then when I distribute, I get AD plus BD equals BC plus BD. Well, if I subtract BD from both sides, I'm left with AD equals BC. So sure enough, they are equal to each other. So for example 1, we're given in the diagram that AC over DF is equal to BC over EF. And we're going to write 4 true proportions. So first I have my original proportion. So AC is 12 and DF is 18, and that equals BC, which is 9, over EF, which is X. So that's my original proportion. Then I can use the reciprocal property and flip them over and come up with another true proportion. So now instead of 12 over 18, I have 18 over 12. And then I also flip over the second one, equals X over 9. If I look at my original proportion and go sideways, I get 12 over 9, and that equals 18 over X. And finally, the last one is if I add the denominator. So I've got 12 plus 18 over 18, and that will equal 9 plus X over X. And so if I simplified that first one, it would be 30 over 18 equals 9 plus X. Then we could use any one of these proportions to solve for X. So if we look at example 2, in the diagram, JL over LH is equal to JK over KG, and they want us to find JH and JL. So JL is this segment right here, and then LH is down below it. Well, JL, they didn't really give me an expression for that. They told me that JH, the whole thing, was X, and that lower part was 2. So I actually need to come up with an expression for JL, so it's actually going to be X minus 2. So now I can set up my proportion. JL, which is X minus 2, over LH, which is 2, is going to equal JK, 15, over KG, which is 5. And so now I can solve the proportion by using cross multiplication. Well, before I cross multiply, I see that I can reduce the fraction on this side. 5 goes into itself once and into 15 3 times. So now when I cross multiply, I have x minus 2 times 1. So that's just x minus 2. And it's going to equal 2 times 3, or 6. So when I add 2 to both sides, I find that x is equal to 8. And so JH has a measure of 8, and JL is 2 less than that, and it equals 6. So here's a chance for you to try one on your own. We're given that BC over AB is equal to CD over DE, and we're going to find BC. So I'll go ahead and let that be X. So set up a proportion and solve it. Pause the video now. Okay, so when you set that one up, you would have X over 12 is equal to 24 over 18. I can reduce 24 over 18 because 6 goes into both of those. So it becomes 4 over 3. And so when I cross multiply, I have 3x is equal to 4 times 12, or 48. And then we divide by 3, and we get that x is equal to 16. So BC has a length of 16. All right, so we can use proportions when we're talking about models, like model cars, model airplanes, or in this case, a model tank. A model of a Sherman tank has a scale of 1 to 16. The length of the actual tank is 584 centimeters. What's the length of the model? And then they tell us the width of the model is 16.375 centimeters, and they want us to find the width of the actual tank. And then finally, the actual tank is 9 feet tall. What's the height of the model in inches? All right, so let's take a look first at A. We're told that the length of the actual tank is 584 centimeters. And up here, we're given the scale of 1 to 16. So the scale is giving us the model to the real thing. So we've got the model over the actual, and that ratio is 1 to 16. So they tell us that the length of the actual tank is 584 centimeters. So that needs to go on the bottom where we have the actual numbers. And then what's the length of the model? We'll just use L up on top. And then we're going to solve that for the length. So if I cross multiply, I have 16L is equal to 1 times 584, so 584. And then if I divide both sides by 16, I get that the length is equal to 36.5 centimeters. Now, if you accidentally set it up the wrong way and you had the 584 in the wrong place, you would end up with a huge number. And then that should set alarm bells off in your head, because we're talking about a model. A model should be smaller than the actual thing. So you should be expecting to get a smaller number for this one. All right, looking at letter B, it says the width of the model is 16.375, and they want to know the width of the actual. So this time they've given us the model instead of the actual. So we would expect the actual one to be larger than the model. So our answer should be larger than 16.375. All right, so again, my ratio is the model over the actual, 1 over 16. And like I said, they gave us the model this time, so 16.375 goes on top. And the width of the actual one, we'll call W, that would be on the bottom. So if we cross multiply, we get that W is equal to 16 times 16.375, which comes out to 262. So the width would be 262 centimeters. All right, so part C, they said the actual tank stands 9 feet tall, and they want to know what's the height of the model in inches. Well, what we have to notice is that they gave one dimension in feet, but they want the other dimension in inches. So again, if we use our ratio of the model over the actual of 1 to 16, the model they didn't give us, that would just be h for the height, over the 9 feet. So when I cross multiply, I get that 16h is equal to 9. So when I divide by 16, I actually get 9/16 of a foot. They want to know the answer in inches. So I have to multiply that because there are 12 inches in 1 foot. And if I do that, my feet cancel out, so that I'm left with inches. Also, I notice I can reduce the numbers because 4 goes into 12 3 times, and 4 goes into 16 4 times. So now if I just multiply straight across, I'll get my answer. 9 times 3 is 27. And 4 times 1 is 4, so it's 27 over 4 inches. And then I'll go ahead and convert that into a decimal. I get that the height is 6.75 inches. That concludes this video. Thank you for watching.